Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And in this tutorial, we're going to continue on with our synth series, and we're going to learn how to use an ADSR to modulate a filter cutoff. So at the end of this tutorial, you will have something like this. So we'll be able to make some acid house or some dubstep sounds now. So before we get started, just wanted to tell you about our audio development community on Discord. You can come join us for free on theaudioprogrammer.com/community. It's a great place to connect with other audio developers, learn more about audio development. So let's go ahead and get started. So first thing I'm going to do is I'm going to just go back to one of my previous commits on my repo. So I will do git log -- all, and then let's see, we will go back to this commit right here. So we will do git checkout this one, and then I will save this so we don't have to keep putting the MIDI in every single time, and I think we're okay there. Okay, great. So let's see, where shall we start? So the first thing that we want to do is, if you've been keeping up with our tutorial series, we have this ADSR that we've created, and what's really nice about this is that at the moment, we're just using it for our amplitude ADSR, but we could actually just create another ADSR object, and that it will actually be able to work just fine for our filter ADSR as well. So first thing that we'll do is we'll actually go to the plugin processor where all of our parameters live. And here we are in our audio processor value tree state. And what I'm going to do is I have these parameters that we created in one of our earlier tutorials. Remember our attack, decay, sustain, and release. And I'm just going to copy these because the ranges and initial values for these are going to be the same for our filter ADSR. So I'm just going to copy all of that, and then I'm going to just create a comment here. I'll just say this is filter ADSR, and then I will just paste this. Now the important thing is that we're going to have to create some unique names for these parameters, right? Because if we have two parameters called attack, the plugin isn't going to know which one we mean. So we need to call one maybe filter attack, right? So, or actually, I'm going to make this a little bit more generic. I'm just going to call this mod, because what we could do later is we could actually use this ADSR, this envelope that we're creating, and we can use it to actually modify other things besides the filter. So we could use it to modify the pitch, to modify FM, or modify other things. So I'll just call this mod attack because it's a modulator. And then I will do the same for decay, sustain, and release. So mod decay, mod sustain, mod release. And now we're going to probably need to do some refactoring as well to make this work. So there we are. We have our filter ADSR parameters, which is really nice. And now let's just go up here. And what we're going to do is we're going to do, so this is in our audio callback where all of our audio is happening, where our parameters are updating. And what we're going to do is this is where we actually get the values for our parameters. And now I'm just going to create just some new ones for our mod attack, mod decay, mod sustain, and mod release. Decay, mod sustain, mod released. And then of course we need to make sure that we have these updated parameter names so we know which parameters that we're getting, that we're grabbing these from. And what we'll need to do is we will need to do some sort of voice. I'll just put this as a comment at the moment. So it'll be something like voice update filter. Okay, so I say update filter, but we have a problem here, which is that at the moment our filter our filter cutoff and our filter resonance is just here in our main processor. So this presents a little bit of a problem. There are a couple different ways that you could actually work this, but what I'm going to do is I'm actually going to take this filter and I'm going to take it out of here and I'm going to move it into our synth voice class. So our synth voice class is representing one synthesizer voice. So if we had like a 5-voice synth, each voice would be a copy of all of this. Okay, and so that means that I'm going to have a filter that's going to be individualized for each voice, which makes sense because if we're playing a keyboard and we were hitting a new note, we wouldn't want that filter, one filter that applies for all the notes, right? We'd want the filter to reinitialize every time we hit a new key, so you get that terrible imitation, but you get what I'm saying. So that's what we're going to do. First thing we're going to do is we're going to go to our plugin processor and we are going to take this filter that we've actually implemented in our last tutorial, and we're actually going to move this back we're going to move this into our voice. So I will just take filter data, I will just take this and move it into our voice. So we'll go over to our voice header. Now, one thing that I find that is very important is to make sure that we have the order of our process chain figured out, right? So, and I'm quite particular about this because I feel like, okay, if in all of our declarations, when we're updating our parameters, when we're going through our process chain, we want to make sure we have the same order for everything. Or else, if we're not consistent, then it's very easy for us to get confused over whether the ADSR would come before or after a filter, for example. So I'm just going to put this here for now, and then I'm just going to erase these other little comments that we made earlier just to clean up our code. So let's think about what we want to do here. I'm actually going to reorder this, and I think this is a good practice. So one thing that I'm going to do, this ADSR is way up here above the oscillator. Okay, I don't want it up there anymore. It's not going to really make a difference in terms of the code, but just in terms of mentally, the way that I want to think about everything, I want it to be very consistent. So I'm thinking that my order is that I want it to be the oscillator first, the ADSR, the amplitude ADSR for the oscillator second, and then there's going to be a modulating ADSR, a modulating envelope that's going to come third, and our filter which is going to come fourth. Actually, I'm going to put the mod after, okay? Because I'm thinking maybe a little bit later I want that modulator to modulate other things, and so that'll be kind of an afterthought. So I will call this. So this is another ADSR, and I'll just call this mod ADSR like this, okay? And as you can see, I moved. There was an error that came up a little bit earlier that said filter data is, it doesn't recognize it, because if we go up here to our includes, we see that we don't have our filter data class included in our synth voice because it was previously in our processor. So what I'm going to do is I'm going to go to my processor header file, and I'm going to take this data filter data.h. I'm just going to remove that because I don't want that to live there anymore. And I'm going to move it over here. Once again, I like to have, I try to have these in order just so it keeps the confusion down. So once again, keeping that order the same: oscillator, then the ADSR, then the filter. Okay, so now that we do that, that error will actually disappear. And of course, all of the stuff that we did with our filter in our plugin processor now has to move over to the synth voice. Okay, so we should get some errors in here. So we have this filter.prepare to play, so that needs to move. So I will do that, and then I will bring that over to my synth voice class there, into prepare to play, wherever that is. once again, we are just looking. We got this ADSR up here. Okay, I don't want that up there. I want that down here. So we're always keeping the order consistent. Okay, so there we go. And then I also have the gain as well. Oh, let's fix this first. So this was get total num output channels. Now this just needs to be called output channels. There we go. So that'll fix that. And then I'm going to have the gain at the end as well. So I want to make sure I have that. Yep. Yeah, so we're fine there. So we have, so that's kind of our process chain. Oscillator, ADSR, filter. Then we have a modulating oscillator, which we will use for now to modulate the filter, but we could use at a later point to modify something else. Okay, so now we got that. And let's see what else. So let's go back to the plugin processor. Let's see what else we need to grab. Okay, so at the moment we're not using these to update anything because we haven't really piped in our new ADSR yet. So I think we're good there. And now what we need to do is so we have this update parameter that updates the ADSR. Okay, I'm just gonna change this to update ADSR just so we know what we're talking about here. Okay, so I'm going to change that to update ADSR. So I'm going to jump around a little bit here in the code. I just want to keep these names really consistent here. So I'm going to call this update ADSR because we're going to update some other things as well. And so if we just keep it with a generic update function, it's not very specific in terms of what we're actually updating. Okay, so now we have that. And so now going back to our modulating oscillator. So this is going to be quite similar, or our modulating envelope rather. We just need to have a look at where we need to actually put some of the parameters or some of these commands. So remember, any DSP process needs to have a prepare to play or some sort of prepare where we're passing it the sample rate. And so we see that with our regular ADSR, says set sample rate. And once again, I'm just going to put this below the filter, and I'm going to say filter or mod ADSR, and then set sample rate. And there we go. So I'm just going to pass it the sample rate. Okay, where else? So when you think about a filter, we want the modulating envelope once again to happen when we hit a key, right? So what I'm going to do is I'm going to go to my start and stop note, which happens when I hit a key and when I release the key, and I'm going to put our note on. So we got mod ADSR note on, and then we have mod ADSR note off. Okay, so that's going to turn on and off our modulating ADSR. Now there's a little quirk about this, about the envelope class about the ADSR class, in that in order for it to work, you actually have to do this apply envelope to buffer in order for this ADSR object to actually work. Now, we don't want to actually apply it to our buffer, right, in an amplitude type of way, because we don't need it to modify the amplitude. We actually need it to modify the filter cutoff at the right point in time. So what I'm going to do is I'm going to kind of do this little trick where I'm going to say, okay, we have this synth buffer where we've initialized it to a size and to samples, and there's nothing in this synth buffer, right? So this is an audio buffer that we've initialized that we're going to eventually put audio into. And we can see that we do this synth buffer.clear to actually clear any contents that may be inside of it. And what I'm going to do is I'm going to actually just do this mod ADSR apply envelope to buffer. And what that's going to do is that's going to actually activate the ADSR. So it doesn't actually do anything to the buffer itself. Even though I'm putting output buffer in there, there's no contents in this or I'm sorry, not output buffer, synth buffer. So I'm not actually, there's nothing in there for it to actually modify, but I just need to activate it, or else it will actually act in a weird type of way. So okay, so there we go. So now we have our node on, we have our node off, we have our we've taken it and we've applied it to the buffer. So now what we need to do is we need to actually hook in to our filter. Okay, so what I'm going to do now is I'm going to go to the filter data class. I will do it in this tab. And at the moment, we have in our filter data class, we have this update parameters function where we are setting the filter type, setting the cutoff frequency, and setting the resonance. And now what I'm going to do is I'm actually going to add another parameter here. So I'm just thinking of what I'm going to do here. So I'm going to add a const float modulator. There we go. And then I need to do that in my header file. Now what I'm going to do is I'm going to make this an optional argument, right? So I will say const float modulator. And then what you can do is you can actually give it a default argument. So this is something that's optional. And the reason that I'm doing that is because if I don't have a modulator there, I want to make sure that that the signal just passes through. So once again, we have this filter cutoff. So we have a filter cutoff frequency that's going between 20 hertz and 20,000 hertz. And if I multiply that by 1, I'm just going to get the same result, right? So that's why I'm setting this optional argument to 1.0. Now what I'm going to do is I need to have a way that so let's go back a step, right? Because I feel like I'm going too fast. The ADSR is going to be producing a floating point number that's going to be between 0.1 and 1, right? And what we're going to do is we're going to multiply that by our filter cutoff, and that's what's going to take our filter, and it's actually going to actually change it, right? So that's why we're doing this. We have this modulator, and this modulator is just a floating point number, and it's just a scalar multiplier that we're multiplying times the cutoff frequency. So what we need to do is we need to get the cutoff frequency, which is just this number frequency, and we just need to multiply that by the value that we're going to be getting from our modulator, right? So what I will say is I will declare a float. I'll call this float mod frequency, mod freak maybe, and I will set it equal to our frequency times the modulator. Okay, so if we have a frequency of 200 hertz and we have this modulator that's just 1.0, we're just going to get the same result, 200 hertz. Now, if we have an envelope in there that is actually going between 0 and 1, now that's going to take it and it's going to multiply times that frequency and give us something besides 200 hertz. Okay. Now, what we're going to do here is we have a situation where what if the frequency is 20 hertz and we multiply it by something that's less than 20 hertz? Then we're going to get, what's going to happen is that we're going to get an answer that's going to be less than 20 hertz, right? And that could be a problem because we don't want our filter to go beyond the parameters that we've set for it. So what we're going to do is we want to actually just limit what that is. And there are a couple functions in the standard library that are great for this. So I will show you those now. So we have this stood f max, and we can look, and it says returns the larger of two floating point arguments, right? So if you have something, so the minimum that we want for this filter cutoff is 20, right? And what it's going to do is we can set it where it says, okay, if the filter is less than 20, we want a 20 to come out, right? So that's what we're going to do here. So we could say mod freak, because this actually returns a floating point number, equals stood max, and which one do I want to make sure that stood f max, sorry. Make sure that you do f max rather than max because you want it to be a floating point number. Very important that you keep your types correct here. And for the first one, I want to say, okay, if the first parameter that I want is mod freak, because I want to see what mod freak is, and 20 hertz. Okay, so that just means that it's going to return whatever the larger value is of this, right? So if mod freak is above 20 hertz, we're all good. If it's below 20 hertz, then it will return 20 hertz. Okay, you with me? So we need to do something for the other side, right? For our max, for the max that we want this parameter to be, which would be 20,000 hertz, right? So we don't want it to go above 20,000 hertz, or maybe it might break our filter, and we don't want that. So now we can say mod freak equals stood f min, and what this does is this returns the less of two values. Okay, so I want to make sure that mod freak is in there, right? Because that's what we're checking. And we want to make sure that it's lower than 20,000 hertz. Make sure that it has that 0.0 and that F to make sure that it's a float. And that's what we that's how you do it. That's how you make sure that your frequency is always between 20 and 20,000 hertz. Now what I'm going to do is I'm actually going to move this into one line. Okay, so let's see, which way shall we go here? I think I like this. Like this. So what I could do is I could actually do this right there. Okay, so some people may prefer to have it as two separate lines. I like to have it as one, feels a little bit more concise there. And now we don't want frequency in there. Now we want mod freak, okay, because that's our modulated frequency. Okay, so there we are. Now we go back. So previously we had this update parameters that with this new parameter modulator. And what we're going to need to do is we're going to need to go to our synth voice, because our filter is now living in our synth voice, right? And what we need to do is for each individual voice, each voice in our synthesizer is going to have its own modulating envelope, which is right here. And what we could do is we could use the command mod adsr get next sample. And what that will do is that will return the next sample that our modulating envelope is at. Now what we want to do is we need to plug that into our filter. So currently what's happening is that we are doing the filter right here, right? So once again, all of this is living out here in the plug-in processor. So what I need to do is I actually need to move this into the voice, because we have filter types and filter cutoffs for each individual voice now. And I'm just going to take that, I'm just going to cut that, and I'm just going to paste it inside this synth.getNum voices, because this is now going through each individual voice and doing that. So once again, let's try to keep everything in order. We got the oscillator, we got the FM frequency, we got the ADSR, and then what I'm going to do is I'm going to take this once again, keeping consistency in our order here, and I'm going to put our modulator down there, okay, below the filter. So I'll just call this mod ADSR like that. If we could just label these really quick. I'll call this amp ADSR like that. Great. So this filter.update parameters, we want that to be inside of our synth voice now, right? And we want to have our filter processing inside each voice. So I'm just going to cut these out for now. And now we have this synth render next block, right? So that will render all the voices, and all the voices are living in here. So this is talking about what's happening in each individual voice. So sorry if you can hear my dog snoring. So now what I need to do is we need to do a couple things. So this mod ADSR get next sample, that's just something I wrote there for now. And I'm going to take the update parameters. I'm just going to comment that out now. I'm going to move that in just a second. But we need to get this filter.process in here. And once again, just keeping the order of this consistent. So we got oscillator get next audio block, and then we have our gain.process. So where is this going to fit in here? So this will fit right here. So filter.process, now we're doing the processing on the synth buffer rather than whatever we had in our plugin processor. And we have this ADSR apply envelope to buffer. I'm going to put this before the filter, right? Like that. Okay. And then, so now we got the oscillator, the amp ADSR, the filter, and then the filter is going to be modified by our mod ADSR. And now what we need to do is we need to actually make that happen and update our parameters. So what I'm going to do is I'm just going to correct all of this. And now we need to make a function really quick. So I will do void. Once again, this is synth voice. And we need another update function. So I will call this update filter. And it's going to take some parameters that I will come back to in just a moment. I just want to paste all of this in here. Okay, so we're going to need the filter type, we're going to need the filter cutoff, and we're going to need the filter resonance. And that's going to come from our plugin processor. Okay, so that's why I put that comment there for update filter. So this will be a const int. Doesn't need to be const. I like to put const there just to show that I'm not intending on modifying that. So I will do const int. This is filter type. The const float cutoff and const float resonance, like that. And then I will do filter the update parameters, and I put that in there. And then we have this mod ADSR.getNextSample. And now what I'm going to do is I'm just going to declare a float. I will call this modulator equals mod ADSR.getNextSample. And remember, if we go back to our filter data class, that we have this optional argument, modulator, right? And that is what we're going to put there. So we are going to we're just going to put in that that optional fourth argument because we want that to modulate our filter cutoff. So now I just need to put all of this in our header file. So here we go. So we got void update filter. And let's see if there's anything that I've missed here. I think we are good to go. Oh, we need to actually call to update our filter. So we got voice update filter, and then we got filter type dot load, got cutoff dot load. We're using dot load because this is a std atomic. You don't need to do that. I like to do it because it just lets me know that the value is atomic, but it's not something that you don't necessarily need to do. And the only other thing we need to do is we need to pipe in our mod envelope attack, decay, sustain, and release. So did we make a function for that? I don't think that we did. So I will do this void. I will create a function called void update mod ADSR, and that will just take these same parameters, just the same as the other ADSR. Just boom, right there. And then I just need to copy this over to the CPP. And void, set the voice, because we need to declare what class for this CPP to look for this in. And now we just update our mod ADSR. So we have mod ADSR dot update ADSR, and in there I will just put attack, decay, sustain, and release, like that. Okay. Now I'm just going to be to be a little bit picky. So I see ADSR has a name in there, so I don't need to call it mod ADSR dot update ADSR, right? It just kind of says something redundant. So just if I'm being picky, what I'm going to do is I'm just going to take off that ADSR there. I'm just going to call it update. And now which means I need to change it in our ADSR class. So rather than calling this, is that something that's, I'm sorry, I might need to put that back because that's actually a juice function. Okay. Disregard what I just said there. So here we go. So yeah, that needs to be called mod because that's coming from a juice function. Okay, great. So now I think we have everything. Oh, we need to go back to our plugin processor and actually do that. So we need to call voice update mod ADSR, and then we got mod attack, mod decay, mod sustain, and mod release. And we can see that this is getting quite long now. So eventually I'm going to move this out to its own function, and these will probably have sub functions as well. They'll probably have functions in themselves. It'll probably be something like update voice, but I'm just going to leave it there for now in the interest of time. So is there anything else that we need to do? I think we're okay. So I'm going to just load this up now, see, and hopefully, there is one more thing that we need to do, one big step, which is that we actually need to, we've actually done all the data stuff now, and now what we need to do is we actually need to create another component. We need to create another visual component for the user to be able to actually modify this. So luckily we already have an ADSR component. Now, what we're going to see is that there is a little bit of a problem here. And the problem is that in our ADSR component class, we actually have kind of hardwired what parameters that we're grabbing from the audio processor value tree state, right? Now, if we want to be able to use this ADSR component again for a different set of parameters, which are going to be our mod attack, mod decay, and so on, we're going to need to make this a little bit more generic, right? So what I could do is I'm going to now just change our constructor where I'm going to take some strings in, and those strings are going to be the parameters that we want to pipe into our component, and then use that. So that way we can just reuse this component. So I'll call this juice string attack ID. And then I'm just going to copy this 4 times. Like that. So we've got attack. And then I'm just going to change this to decay. Sustain. Oh, if it quits moving on me. Sustain. And release ID. And now what I'm going to do is I'm just going to call this attack ID, decay ID, sustain ID, and release ID. Okay, I'm actually going to do something else, which is that at the moment, the component itself is just called envelope. I'm actually going to just change, make it where that's going to be able to be modified. So I'm going to call this, I'm going to set another parameter called juice string, and I'll just call this name, and that will be our component name, so we can actually change the name of the component. Okay, and now what I need to do is I'll create a string that's called component name. So I'll call this component name. I'll set it equal to name, like that. And then going over to our ADSR component down here, I'm just going to create a member variable called juice string component name. And I will just initialize it with just blank, just as blank for now. And then of course, down here, this now needs to become component name. Oh, with a lowercase. There we go. Oh, I hate when it does that. There we go. So now we've done that. And let's see. So now I just need to update my header file for this ADSR component with my new constructor. So previously it was just the audio processor value tree state, and now it's all of that business. And now what I need to do is I actually need to update it in the editor as well. So in our editor, which is the parent component of all of our visual components, we will see that we have our ADSR that we have declared here, and now I need to give it all of its proper names. So this is our amp ADSR, so I'll just call this amp envelope, like that. Then it takes second parameter as the audio processor value tree state, and then I'm not spelling this right. And there we go. And then we have our attack, decay, sustain, and release parameters. Those parameter names that we need to put in. So we got attack, decay, sustain, release, like that. Okay, so now that is fine. And now if we come into our plugin editor, what we're going to do is we need to create another ADSR component, right? Because that's what we need to modify, be able to modify the filter. So once again, trying to keep these in a consistent order. So we're going to have oscillator component, ADSR, We got our filter, and then this is going to be called our mod ADSR. So I'll call this ADSR component mod ADSR, like that. That's going to go after our filter. So now we call this mod ADSR, and we just need to put in these arguments, right? So I'll just call this mod envelope. And then we just need our audio processor value tree state object. So audio processor APVTS. And then this was called mod attack. Mod decay. Mod sustain. Mod release. There we go. Now we need to add it and make it visible. Add and make visible. This is mod ADSR. And now in our resized, we just need to actually draw it. So let's see here. So we got the we got the oscillator that's at the top left. We have our amp ADSR, which is at the top right. Then we have the filter, which is down at the bottom left. And what I'm going to do is I'm going to put our mod ADSR in the bottom right. So we do set bounds. We want to put it to the right of the filter. So what I could use is filter get right. And then the Y will be, so it's on the second Y we did this. This is why it's really nice to have these variable names that we created earlier. And then for some reason I noticed that we made this 280 rather than 300. I'm actually going to make this 300 now. And now that I have, see how we have all these and they're the same size? That seems like a good sign that I just need to move this out to as a variable. Makes it a little bit more readable. So if we decide to change the dimensions, we don't need to do it individually. We could just do it. We can just do it by changing one number. So I will just set this at 300, and then we'll do a const auto height equals 200. And now I could just call this width, height, like that. I could just do that for all of these, like so. And there we go. So I think I'm going to need to make this just a little bit bigger. So I will make this 620, just make the parent component, our actual plugin, a little bit wider. And I think that's everything. I hope. I hope I haven't missed anything. Seems like an error may be popping up. Okay, looks like it's gone. And now we get build succeeded. Okay, so hopefully this all works. So now I'm just going to actually load our recent set, which I just called test. And in here I have the plugin loaded already. And I'm just going to change it to a square. Just going to open the filter. Sounds like it's working already because I could hear it kind of slightly coming off. So I'm just going to turn the filter down to like maybe 400 hertz and then turn the attack. So now we do that. I'm going to turn this down a couple octaves because I love the bass. There we go. Let's turn the release of this up, turn the release of the amp up a little bit. Give it some res. Nice. Yeah, so that's really it right there. I mean, we could just keep going on with this. Make a little bit of put a little bit of FM in there. Right? Pretty cool, huh? So yeah, so that's really the basics of it. I mean, you can really do quite a bit off of this, right? So one thing that you see in filter in mod envelopes is mod depth, right? And maybe what we'll do in one of these tutorials is actually adjust the mod depth where you can make it 10% of the mod of what this mod envelope is doing, and so it's only modding a little bit. Or you can make it where maybe it goes in the reverse, right? Where you can take this mod envelope and you can actually flip it around the negative values where it's actually taking the filter and it's pulling it down and then back up, things like that. So that's a lot. Yeah, there are a lot of ways you can extend off of this. You could also do the same sort of concept with an LFO. So you take a low frequency oscillator, and now you use that to replace the mod envelope, and now you can use an LFO to modulate the frequency. And we'll do that. We'll probably do that in the next tutorial, actually. But yeah, that's really it. I hope you enjoyed this tutorial. If you have any comments, if you have any ways to improve on this code, and if you have any suggestions, we would love to hear them. Please put them in the comments. If you found this helpful, please be sure to like and subscribe and all that business, and we will see you next time.